Hi guys, so today we'll be doing Pythagorean theorem in trigonometry to find the exact values of trig functions, right? So let's start with an equilateral triangle. So let us suppose we have an equilateral triangle and we know that all the angles of an equilateral triangle are 60 degrees. Right? So let us suppose we have an equilateral triangle and then we divide this equilateral triangle in two equal parts. All right, so we draw a 90-degree angle. So we draw a 90-degree angle, or we draw an altitude. All right, so when we draw an altitude, it's going to have a 90-degree in the middle, and we divide the equilateral triangle into two equal parts. Right, so now the new angle that is formed looks like this, right? So we have a 30-degree angle on the top because the 60-degree now is divided into 30 and 30. So we have a 30-degree, we have a 60 degrees here, and when we have a 90-degree angle at the corner, right? So now we can say that, let us suppose the sides of the equilateral triangle is x. All right, so if the sides were x, we know that the hypotenuse will be x. The base, if the total side was x and we have divided into half, the base is going to be x over 2. So the base is x over 2, and hypotenuse, we don't know it yet. So let us suppose that is L. All right, so let's find L using Pythagoras theorem first. So we can say that x square, that is our hypotenuse, will be equals to L square plus x over 2 square, and this is using Pythag theorem. All right, so now x square will be equals to L square plus x square over 4. Right, so leave L squared there, and then we can say x square minus x square over 4. Right, so that gives us, now one thing to, just an algebraic thing is, if one side is equals to like L square, we can also write it as L square is equals to x square minus x square over 4. It's exactly the same thing. Sometimes students don't get it, but that's an easier way of doing it, just moving the entire left side to the right and entire right to the left, just so it looks nice and it's easier to solve. So now let's solve the fraction. So if we have 1 here, we times by 4, and that will give us 4x square minus x square over, now the denominator is 4. So that leaves us with 3x square over 4. All right, so now we have L square is equals to 3x square over 4. So square root on both sides will give us L is equals to square root of 3, and square root of 4 is 2, and square root of x squared is x. All right, so L is equals to square root 3 over 2x. All right, so now we have got all the sides. So let us draw the triangle again. All right, so let's draw the triangle again. We know that this is 30 degree, this is 90 degree angle, and this is 60 degrees. This is x over 2, and now the perpendicular is 3 over 2x, right? So now we can find sine, cos, and tan, secant, cosecant, and cot using the SOHCAHTOA function. All right, so let's find sine first. So sine theta, we know that it is opposite over hypotenuse. All right, so sine, here we are using 60-degree angle first. So sine 60 degree is equals to opposite, and opposite in this case is root 3 over 2x. So that is root 3 over 2x over hypotenuse is x. Right, so here x divided by x is 1. So sine 60 is equals to root 3 over 2. Right, so now similarly we can find cos theta. So cos theta is adjacent over hypotenuse, and cos 60 degree, again we are using the same 60 degree, cos 60 degree will be equal to adjacent, and our adjacent is x over 2. So x over 2 over hypotenuse is x. So cos 60 degree is equals to half divided by 1 is going to be half. So it is half. All right. So now we have two values. Now let's find tan. So tan theta will be equals to opposite over adjacent. So tan 60 degree will be equals to opposite, which is root 3 over 2 x, and over adjacent, which is x over 2. All right, so now this is a division. So to solve this division, I would do tan 60 degree is equals to, just write it as a division. It just makes it easier, divided by x over 2. And we know that to convert division to times, we can flip the last fraction. So times 2 over x. All right, again, x divided by x can cancel, 2 can cancel, 2 divided by 2 can cancel, it's 1. So you're left with root 3. All right. All right. Now we have find sine, cos, and tan. We will find the next three reciprocal functions as well. So now the reciprocal function, the first one is cosecant or cosec theta. And cosec theta is just reciprocal of sine. So if sine theta is root 3 over, so sine 60 degree is root 3 over 2 h over o. So we can write cosec 60 degree is going to 2 over root 3. We are just going to do reciprocal of that, right? So similarly, sec theta is reciprocal of cos, so it's going to be h over a. So sec 60 degree is going to be 2 or 2 over 1. All right, and last one is cot. So we have cot theta will be equals to adjacent over opposite, and cot 60 degree is equals to adjacent. So we've got tan 60 is root 3, so it's going to be 1 over root 3. Right, so that is what we have got using the 60 degree angle. Now we can do the same using the 30 degree angle. All right, so now for 30 degree, our opposite side is going to be x over 2, and our adjacent side is going to be root 3 over 2. Right, so now let's draw the triangle again and find the 30 degrees. So let's draw the triangle again, and this time we are using the 30 degree angle. All right, we are not using the 60 degree. So we know that is x, that is root 3 over 2x, and that is x over 2. That is 90 degree. So this is our opposite, and this will be our adjacent and hypotenuse. All right. So now again, sine 30 degree will be equals to opposite over hypotenuse. So that will be x over 2 over x. So that is going to be 1/2. Okay, because x divided by x will give us 1. Right, then cos 30 degree is adjacent over hypotenuse, and adjacent here is root 3 over 2x over hypotenuse is x. So that leaves us with root 3 over 2. Then we do tan 30 degree, and tan 30 degree is opposite over hypotenuse. Sorry, opposite over adjacent. So opposite is x over 2, adjacent is root 3 over 2x. Again, we are going to write it as division just to make simplification easy. So that will give us x over 2 times 2 over root 3x. Sorry, root 3x is in the denominator. So now another way of solving could be 2x over 2 times root 3 times x. X and x cancel, 2 and 2 cancel, so you're left with 1 over root 3. All right, so now let's find the reciprocal functions. So that will be cosec 30 degrees is equals to 2, because we are just going to do reciprocal of the sine function. Sec 30 degree is equals to 2 over root 3, and cot 30 degree is equals to root 3. All right, so these are few values that we have found so far using the triangle, right? Using the equilateral triangle. Now, we have so far found 30 degrees and 60 degrees, right? We can also find 45 degrees in there. All right, so now let's find the exact values of 45 degrees, and when after finding that, I'm going to put it together into a table and will give you a really good short method to memorize all these exact values. All right, so first hang in there to learn how to find the exact values of 45 degrees, and once we have done that, then you will have a bonus short method to learn all these values. All right, so just stay in there. So now we are going to start with a new triangle with 45 degrees angle. All right, so now again we have a right angle triangle. So we have a right angle triangle, and we know that if one angle is 45 here, the other needs to be 45 as well, right? Because that adds up to 180 degree. Okay, so that is our hypotenuse, and we have the sides equal as x and x, because if the angles are equal, their opposite sides are also equal, right? And now in this way we can find, using Pythagoras theorem, we can find the value of h in terms of x, right? So we can say h squared is equals to x squared plus x squared. So h squared is equals to 2x squared. Now square root on both sides will give us h is equals to root 2x. All right, and we are going to use this root 2x there. Okay, so let's get started. Let's quickly draw the triangle again. So that is 45 degrees, 90 degree. We don't need that because it's the same angle. So now this is root 2x that we have just found. This side is x and this side is x as well. Okay. So let's find sine theta first. So sine theta is equals to opposite over hypotenuse. So sine 45 degrees will be equals to opposite. So if this is 45 degrees, this x is opposite and adjacent is also x. Amazing. So we have opposite is x over hypotenuse is root 2x. So x and x will cancel, so we will be left with 1 over root 2. All right, then cos 45 degrees, cos 45 is adjacent, adjacent is also x over root 2x, so that is the same values. So sine 45 and cos 45 are the same values, right? And then we are left with tan 45 degrees, and tan 45 is opposite, which is x, over adjacent, which is also x, so that leaves us with 1. Okay, now let's do the reciprocal functions. So we have cosec, which is 1 over sine. Cosec 45 degrees will be equals to the reciprocal of sine. Sec 45 degree is going to be reciprocal of cos, so that is again root 2. And cot 45 is reciprocal of tan, which is 1. All right, amazing. So we have now found few of these values. Now the bonus or the method to memorize this. So what we do is we create a table, right? On one side we will write the functions, right? So we write sine theta, cos theta, tan theta, then cosec, because it is sine, so we should write cosec first. So cosec theta, sec theta, and cot theta, right? So we write the functions and then we write the angles here. All right, so we start with 0 degree. We'll come back to it. Then we have done 30 degree, we have done 60 degree. Oops, we did 45 as well. So 45 degrees, we did 60 degree, and we're going to do 90 degree as well. So 0 and 90. I'll just let you know soon. Now just let's draw it as a table, and then we are going to just fill in the values. And I'll tell you a shortcut method to memorize those, all right? So this is just to memorize that in exam you can just quickly draw a table on the side of your paper, and then you can use those values, right? So now let's start with the sign. You start with 0, so you start with 0, 1, 2, 3, and 4. Then you write over 4, over 4, over 4, over 4 in all the cases, and then you square root it. So that is all that you need to memorize, right? Now just simplify those. So when you simplify, 0 over 4 is 0, square root will be 0. Square root of 1 is 1, and square root of 4 is 2, so that is half. The next one is square root of 1 over 4 is half, and then you do square root will give you 1 over root 2. Next will give you root 3 over 2, and 4 over 4 is 1, will give you 1. All right. Now for the cos function, you write it from the back, right? So you write 1. So 1 comes the first, then root 3 over 2 comes next, then 1 over root 2, then comes half, and then comes 0. All right, pretty easy. Now with the tan, we know that tan is equals to sine theta over cos theta. We know that, so we are just going to divide it. So 0 over 1 is 0. Half over root 3 over 2 is going to be 1 over root 3. Same numbers, 1 over root 2, 1 over root 2 will give you 1. Root 3 over 2 over half is going to give you root 3. And 1 over 0, you cannot divide anything with 0, so that is not defined. Okay, now again, the next one, cosec. Cosec is 1 over sine, so you are just going to flip that number. All right, so now you have 0, so 0 over 1, and when you flip it, it will become not defined, 1 over 0. Now half, when you reciprocal half is going to give you 2, 1 over root 2 will give you root 2, 2 over root 3, and 1. Okay, with cosec, again you write it from the other way around, so that is 1, 2 over root 3, root 2, 2, and not defined. Cot is 1 over tan. You can write just reciprocal of tan, or you can just divide cosec. So cot theta is equals to cosec theta over sec theta. You can either do it this way, or you can do 1 over tan theta. Okay, so that's again going to give you the same thing. So I'm just going to do 1 over tan. So 1 over tan, 1 over 0 is not defined. Then we have root 3, 1, 1 over root 3, not defined, 0, it's going to be 0. All right, so I hope this makes a little bit of sense. All right.